objective of this lesson is to graph and write equations of parabolas. And we are going to start here with an application of parabolas, and that is to make wall heaters. And the source of the heat is this point here we call the focus, and you can see the heat source is the focus, and the heat is concentrated in parallel rays. You also see application of parabolas on satellite dishes. So those are two applications of parabolas. And let's look at some vocabulary associated with the parabola. And the first one is the focus. And the focus here lies on the axis of symmetry, so the middle of the parabola. We also have the directrix, which is perpendicular to the axis of symmetry, makes 90 degrees. And then we have the vertex, which is halfway between the focus and the parabola. And note what we say in the definition. So it is a set of all points equidistant from a particular point called the focus. For example, you can see this is equidistant from the focus and the directrix. And every other point, for example, if I make a line there, let me show it here. If I draw a line there going all the way to the directrix, see, that's going to be, doesn't look like it because it's not drawn to scale, but that's going to be equidistant. If I make another point here to this point, 90 degrees, it's going to be equidistant. So all the points which are equidistant from directrix and to the focus. And now let's move on to the next slide. And this is how you can generate a cross section of a parabola when you cut the shape sideways. You can see here you'll generate a parabola. And now, very important here to know the equations of parabolas. So right now we are focused on the vertex of the parabola being at the origin. So that is at 0, 0, and the equations will be as follows. So you can see here we have x squared is equals to 4py, and the focus will be located at 0p. Directrix as y is equals to minus p, and you can see the axis of symmetry is at x is equals to 0. And you can see how the graph looks like. It can open up if p is positive. It can open down when p is negative. Okay, and again here, if the parabola is opening sideways, you can see the equation we are going to use. The focus is p0, directrix will be on the opposite side, and the axis of symmetry is at y is equals to 0. Note it can open to the right if p is positive, open to the left if p is negative. Okay, now let's move on. And here we're going to do some examples. Let's do some examples here. And we start with the equation given here. So the equation given is x is equals to 1 over 4y squared. So the first thing I would do with this equation is to take the equation and rewrite it in this format here. So I can do that by multiplying by 4, multiply by 4. So I get y squared is equals to 4x. So that's the equation. Now the next thing I need to do is to compare it with the general equation of a parabola with an equation like this one, which is y squared is equals to 4px. And now I need to highlight what I need to pay attention to. I need to pay attention to 4 and to the 4p. So since they are equal, here I can write 4p is equals to 4. 4p is equals to 4. So p is equals to, if I divide both sides by 4, I get 1. So that means the focus is going to be 1, 0, because I know the axis of symmetry is on the x-axis, so it's the horizontal, or y is equals to 0. And then the directrix is given by x is equals to -1. Okay, so that's the directrix, and that's the focus, and that's what I was supposed to get in this case. Okay, so that's done. Okay, now let's go to the equation we just obtained. And if we want to graph this function, see, this is the equation, and remember, where did this one come from? See, this is coming from the equation we got on the other side. Remember, it was y squared is equals to 4x. See, I can write this equation. To graph it, I can find the square root of both sides, and that's how we get plus or minus square root of 2 of 4x. And that's the equation right there. So let me start by plotting the focus. So the focus is right there, and the directrix is on the other side. So that's the directrix over there, that line. I made it dashed, and then I just need a convenient value to put under the square root that will be able to get good numbers. So if I plug in 1 for x, if x is equals to 1, what do I get? Plus or minus square root of 4 when x is 1. So that means it's y is going to be plus or minus 2. So when x is 1, I get y is equals to plus or minus 2. So I just need to plot that. So 2 and minus 2. And now all I need to do is to connect my points. And there's my sketch of the parabola. And see, when you graph it using technology, this is what you get. Let's do another example here. So here we are given an equation. So to proceed with this one, I need to rewrite it. So I'll multiply by 4 over 3. That way I can get rid of these numbers. So 4 over 3. So what does that mean? I get y is equals to 4 over 3x. And now I just need to identify the 4p and 4 over 3. And I'm going to write 4p is equals to 4 thirds. And then I can divide both sides by 4. So I divide by 4 here. See, this is gone. So p is equals to 1 over 3. What does that mean? The focus is going to be 1 over 3, 0. And the directrix is going to be x is equals to negative 1 over 3. And see, I have my equation now. And don't forget, see, this is what I'm supposed to get. So let me highlight it. And don't forget the equation is 4 over 3x. We're going to use it to graph it on the other side, on the other page. See, when I have this equation, I forgot to put the y squared here. So if I have this equation, remember I could get the square root of both sides in order to graph it. So plus or minus square root of 4 over 3x if I want to graph it. Okay, so here, this is my equation. If I want to, and we are going to do that. So this is the equation. This is all the information we got from the other side. And let me start by plugging in the focus. So about there, a third. And here, when x is, I'm looking for a convenient number. If I plug in 3 for x, then what do I get? Plus or minus square root of 4 times 4 over 3 times 3. See, that will be gone, so I'm left with plus or minus square root of 4. So when x is 3, I get y is equals to plus or minus square root of 2. So when x is 3, it's going to be plus or minus 2 for y. And here is my parabola. That's a little off. See, that's my parabola when I graph it. Actually, for mine, I forgot to do my directrix over there. And here is the parabola when you use technology. See, this is the parabola when you graph it using technology. You can do this on Desmos. Okay, now here we are told to write an equation of the parabola. So the axis of symmetry is x is equals to 0, or the y-axis, and the focus, I can read the focus, it's 0, -1, and the directrix is on the other side. So the directrix is y is equals to 1. See, remember the p is -1, so negative 1. That's how we get 1. So the equation, so the parabola is opening down, so that means it's of the form x squared is equals to 4py, and I already see p is equals to -1 because it's opening down. So x squared is equals to minus 4y. So that will be the equation of this parabola. Okay, now we are going to let's do another example. So here you have a parabola. The axis of symmetry is y is equals to 0, or the x-axis. The focus is half 0. The directrix is going to be on the other side, -1 over 2. So the equation is going to be y squared is equals to 4 times half x, because p is equals to half. So what do I get finally for the equation? For my equation, I get y squared is equals to 2x. Y squared is equals to 2x. And if I wanted to graph it, like if I can find the square root of both sides, and that's how it looks like when we graph it using technology. Okay, our last example here, find the equation in standard form for the parabola whose directrix is at the line x is equals to 3, and the focus is there. So what we shall do here is to sketch it. That way we can have a good sense of where it is. Directrix is at x is equals to 3. So directrix is right there. Let me use a different color for directrix. So that's the directrix at x is equals to 3. And then the focus is on the other side. And so we know the parabola is going to be opening in this direction. So, and since it's opening, so both sides, which will be plus or minus 2x. I wanted to graph it. I can do that like in a graph. Okay, so that's my graph right there. That's how it's going to, that's my sketch here. So I know it's going to be on the form. It's going to be of the form y squared is equals to 4p. Why? Because it's opening sideways. I also know that p is equals to -3. And so the equation is just going to be y squared is equals to -12. Oh, what did I do here? See here, I wrote see 4px. So y squared is equals to 4 times p. So p, remember, is -3 because it's opening to the left. So that becomes y squared is equals to -12x. So that's how the equation is going to look like for that parabola. And you can see it right there when graphed using technology.